Friends, welcome to the channel God is Science or Science is God. I am Sanjay Dosaj with a new, interesting, and intriguing video. In the last episode, we discussed evidences to prove that space-time is a physical entity. However, today we will analyze what type of a physical entity it is. The Hindu scriptures refer to it as Kshir Sagar, an ocean of fluid, and traversing beyond it is moksha, liberation from the cycle of birth and death. This subject we will discuss in another episode. For now, we will stick to the subject for today. That is, what evidence do we have to prove that space-time is a superfluid? Before we begin today's video, please like and subscribe the channel and press the notification icon so that you get a notification for the upcoming videos. Like and share the video on all platforms and in all groups if you like it. If you are a professional, researcher, or expert in the field and wish to discuss more on this, please come to the comments section of the YouTube channel. So now let's begin with today's video. To understand which properties of space-time make it close to a superfluid, we should first have a glimpse of the properties of a superfluid. A superfluid possesses the properties of a normal fluid and a superfluid. A superfluid has zero viscosity, hence flows without any loss of kinetic energy. It does not offer any friction. They have no intermolecular attraction, hence superfluids are a collection of individual particles instead of a fluid. They behave like a collection of neutrons. When stirred, they will continue to flow indefinitely. As per the superfluid theory of everything, we describe dark energy as a quantist, fundamental, and ubiquitous scalar field possessing superfluid features. Since it flows friction-free, once the speed is increased equal to the speed of light, it will continue to flow at the same speed. What is space-time? This question has always intrigued thinkers, scientists, and dreamers alike. So now, what if we told you that space-time might behave like a superfluid? Intriguing, isn't it? Let's now have a look at the properties of space-time that make us to believe and recognize it as a superfluid. Firstly, space-time does not interfere, interact, or offer any friction. It is like a perfect dance partner, moving in harmony with the universe, never missing a beat. It doesn't push back or resist like air or water might. It simply allows the universe and everything in it to move freely. Secondly, space-time has mass. This might come as a surprise. After all, how can something invisible and intangible have mass? But when we look at the galaxies, we find they have more mass than can be accounted for by the visible matter alone. So, where does this extra mass come from? The answer, as strange as it might sound, could be space-time itself. This mysterious mass that we can't see or touch, we often refer to it as dark matter. But it could very well be space-time. Thirdly, once space-time gets stirred, as in a black hole, it flows indefinitely at the speed of light. This is a fascinating concept. Imagine stirring a cup of coffee and the swirls keep going at the same speed forever. That's how space-time behaves in a black hole. It's a perpetual motion machine on a cosmic scale. Next, we come to the viscosity of space-time. In simple terms, viscosity is a measure of a fluid's resistance to flow. Honey, for example, has a high viscosity, while water has a low one. Space-time, it turns out, has zero viscosity. It offers no resistance to motion. It's the ultimate smooth operator. Lastly, space-time is affected by temperature. Just like the density of air changes with temperature, so does the nature of space-time. This means there is a variation in temperature depending on the location, event, or phenomenon in space. Hot stars, cold voids, violent explosions each affect space-time in its unique way. To summarize, space-time is a unique entity that does not interfere or offer any friction, has mass, flows indefinitely at the speed of light when stirred, has zero viscosity, and is affected by temperature. These intriguing features suggest that space-time behaves like a superfluid. It's a concept that challenges our understanding of the universe and offers exciting possibilities for future exploration. So the next time you gaze up at the night sky, remember, you're not just looking at stars and galaxies. You're witnessing the cosmic dance of space-time, the superfluid that shapes our universe. Puzzled, confused, or convinced? Leave a comment in the comments section. Please like and share the video and subscribe to the channel before leaving.